All right, so today we're going to take a look at how to solve a system of equations using a method called substitution. All right, so to start off with, here's a system of equations. You've by now seen them in a few different contexts, and you even know at least one strategy for solving it. Right, so you could take each of these equations and graph them on the plane. You graph y equals 3x minus 9, pretty easily because it's in slope-intercept form, and you could take 5x plus 4y equals 32, and using one strategy or another, maybe turning it into slope-intercept form, for example, you could graph that as well, and then you would look for something in order to know whether you've got the solution. So what you'd be looking for is you'd be looking for the intersection or the place they cross. And that's a point, right? That's a point x and y. There's other strategies that you might have seen by now. For example, if you have some examples that might be the answer, say you thought the answer could be 4 or 7, you could plug those values into each equation, make sure they check out, and if they do, well, you've got the solution. And that's something that might work, say, for example, on a multiple choice question on a test like the MCAS. But what we want to look at right now is something beyond just graphing or plugging in. We want a new strategy, and it's called substitution. So it's actually not that dissimilar from just plugging in from our answers. It uses really the same basic idea. And what it allows us to do is just work with the equations, right? No graphing necessary. And really, the biggest skill is equation solving in this, which is something that you already have some familiarity with. So here's how it works. We've got our two equations, y equals 3x minus 9 and 5x plus 4y equals 32. And because they're a system, right, they work together. They've got the same thing going on, and you're looking for the place that they cross. So you're looking for the place where x and y are exactly the same thing. And this strategy takes advantage of that. So here's basically how it'll work. You notice that you have y is 3x minus 9. That's what that says. And notice that, we've got this green y up here. And we've got this blue y here, but they're the same thing. They're both just y. They do the same job. They're representing the same number. So we could really just switch those out as much as we wanted. It really wouldn't make any difference. I think that's pretty obvious. But what might be a little less obvious is this first sentence, this equation up here, says that y is 3x minus 9. It's the same thing. They're interchangeable parts. So just like we could take this y and swap it out, we should also be able to just take 3x minus 9 and swap it out in the same way. Now, we need to make a little bit of room to do that, but we can still just swap it out. The only thing I'm going to add in here is that because this was 4 times y, we really need to swap this out in parentheses to make it clear that it's 4 times that whole thing. And you might be sort of wondering, okay, Mr. Don, why are we doing this? Now I just have this really ugly looking equation. And that's true, but the nice part about it is, ugly as it is, it's a single equation with a single variable in it, which means we can solve it. So go ahead and solve it. All right, so hopefully you got it, but let's take a look at how this would be solved really quick. I'm going to say that we're going to distribute in with this 4. And we'll wind up with now 5x from 4, plus 4 times 3x, which is 12x, plus 4 times negative 9, which is negative 36. It still equals 32 over here. we're going to have to combine some like terms here. 5x and 12x get us 17x. Minus 36 equals 32. And as well, we're now going to add our 36 to both sides to get the 17x by itself, right? So plus 36 on both sides, which will get us that 17x equals 32 plus 36 is 64. And so, oh, and sorry, I added incorrectly. 32 plus 36 is 68. Then we're just going to divide both sides by 17 to get us that x equals 4. So hopefully you got that. But this is, this is obviously, you see all the steps. This is the place where mistakes are most likely to happen, but it's not even new. The new part was up here, that substituting in part. And really that's the only new thing you're learning, is that plugging in. So we've done that. We have x equals 4, but we know as far as our solution that we need two things, right? We've got that x is 4, but we still need y, right? So the nice thing is that, bringing this, this piece back, all that back in, we know that since y equals 3x minus 9 in the first place, that we can still just take this x, just like we substituted before. We can take this x and trade it out for this x. So this x becomes 4. Again, this is from the plugging in strategy before, and it's the same thing as what we just did right here with substitution. So y equals 3 times 4 minus 9. So y equals 12 minus 9, which means y equals 3. Right? And that's it. That's the substitution strategy. So especially if we have one of our variables solved for one of the numbers, all we have to do is plug that expression back in, solve the equation, plug the point back in real quick, calculate it out, and we're done.